Hey there guys and gals, it's me nirex and welcome back to Beginner C++ Programming. So in this video we're going to talk a little bit about functions. Now as you can see I've already added another topic which is the recursive functions, which is the topic after this one. But this video is going to take long enough, so we're not going to talk about this one in this video. Now we're going to talk about these guys in this video. Let's get right into it. So there are 6 little topics that we're going to talk about. Number 1 is calling functions, function declaration, function definition, parameters versus arguments, default parameters, and the return type and the return statement. So that's basically it. Now let's get right into this one, calling functions. Well, as it turns out, you've already been using a function so far, and this guy right here is our function. So whenever we want to call a function, we just give the name of the function, as usual. Functions have names like everything else, so we give the name of the function, open and closed parentheses, and in here we give, some random junk, which we'll talk about that, right here. And that's basically it. So whenever you want to call a function, you just do it like this. Give it the name, open and close parentheses, and then give it whatever value you want, or whatever arguments you want, or whatever value you want to give its arguments, or whatever, okay? And then you close it off with a semicolon. And that's basically it. Now, let's get right into function declaration. Well, it's better to put that guy right there, okay? Function definition, then function declaration. Now, function definition, as it turns out, you've already done that as well. This guy right here is the function definition. But I'm not going to just go ahead and define a function just like that before explaining it and what it does and how it's related to math. So as you may or may not know, we already have functions in the world of math. And they're represented like this. Usually we have the f of x. Okay, usually, not all the time. And f of x means function of x, some random function of x that does something for us. So when creating a function in math, we do f of x is equal to some random formula. It could be x times x, for instance. So this is a square function. We can just write the name and change the name as sqr. So square of x is x times x. We also have other kind of functions. So we have sine of x. Okay, we have cosine of x. We have tangent of x. We have tangent hyperbolic x. Okay, so we have a whole lot of bullshit right here. Okay, and we don't really give a damn about them. All we care about is this guy right here. Okay, so a function name with a parameter is equal to some formula, and we're going to do the same thing here. Let's create a function, just like that. Let's create this exact function. So the name is sqr. I'm going to do a sqr of x, and then we open and close these little guys right here, the curly braces, and then write our formula. And obviously we put a semicolon here, but there's an issue here. The issue is, as I've already told you, computers are absolute dumbasses, right? They don't know what the hell is going on. They don't know anything. So for them to know something, they don't know what x is. Identifier x is undefined. It means that we don't know what x is. You could do something like this. Now x is defined, of course, but it's bullshit, right? Undefined gets fixed like that, but it doesn't really mean we should do that. It means that it doesn't know what x is, okay? Now we need to fix that. How do we do it? Obviously, we need to give it a type. So int x, now we have an int, and operation is being done on our little int right here. But there's still an error. Explicit type missing. Explicit type is missing int assumed. So int assumed is just assuming that it's int, but it doesn't know what the hell we're gonna do. So as I've already said again, computers are dumbasses, kind of. So they don't know what this is, alright? Just yet, they don't really know what the heck is going on. They don't know what this is. you can do something in math world like this. You can do 2 plus the SQR of 10. Square of 10 is 100, and 2 plus 100 is 102. So this guy right here will result into 102, right? But that's the thing. We as humans know that we must replace this little symbol right here with the value it's going to give us, with the calculated value right here. Now, this guy right here will be evaluated into 100, but what the hell is 100? Is it a string? Is it a floating point number? What the hell is it? Well, obviously it's a number. So that's why we need to tell it, when we call this function, what should it be replaced as? Which is int, right here. And int assumed, as it was saying, explicit type is missing. Int assume means it's going to automatically assume that it's int, but we're still going to have issues when we're trying to compile. As you can see right here, explicit type is missing, int assumed. So even if it just automatically assumes that this is our type, you still need to put it there. So we can say int sqr int x. Now, whenever you type sqr, it calculates the thing and it replaces the value with an int value that is generated or evaluated from this formula. Okay, so it calculates this, replace this guy with this guy as an integer type. Now, I could just put double here. It would replace it as a double type. But I'm just going to put int. Okay? And there we go. Now, there is not an issue here, but there is, honestly. It's not giving me an error, but there should be an issue. If I try to type it, if I try to compile my application, it's going to be giving me an error saying sqr must return a value. Now, think of it as this. When we call a function, our line of execution, the pointer that is executing each line, well, I shouldn't be saying it like I don't know what a pointer is just yet. So the pointer that is executing every line, the thing that is executing every line and going down line by line, is going to get into this guy, and it's going to go inside this function, execute each line, and then come back out of the function. Go to the next line. But here's the thing. When our cursor, like this guy, gets into the function, when the execution line goes into the function, it could take something back out of the function and replace the function with that thing, whatever it took out. And that thing is known as the return or the return value. So when we want to return something, when we want our function to be replaced by something, we just put a return here and we return whatever we want to be returned. We could do something like int ret value equals x times x and then do return ret value. It's just redundant, but we could do it. So we calculate something, we return that thing. I could write a max function, just the way we did it with if. I could do it with a function. I could write whatever I want with a function. And that's basically what a return type means. So when trying to find the maximum, we just do something like that. We check which one's the bigger one, and then we return that out of the function so that we have the maximum value. And that's basically it. So now we know calling functions, which is done. We know function definition. We don't know declaration yet. We don't know this guy yet. We don't know this guy yet, and we know this guy right now. So we know what the return does. Okay, the return type and the return guy, or return type. Come on, and statement. So this is a return statement. This is a return type. All right, that's basically it. Now let's talk a little bit about function declarations and definitions. So whenever you open and close these guys for functions, and there is no semicolon here, you could put one there, but there really isn't one. So just don't do it. So whenever you create a function like this, you are defining a function, okay? You're creating a function and you're giving it what to do. And this is called definition. Function definition is like this. But here's the issue with function. There's a rule here, all right? One of the most important rules is that functions can only be called by those below them. Okay, so if I put something here, as I already told you, functions can be called like this. Okay, so let me just first create another function, a more simple function, sqr, or rather, just foo for testing, which takes no parameter, no argument, nothing. If I try to call foo, if I try to compile it, foo identifier not found, but it's right here. It's not found because it's out on the top. Main doesn't know that foo exists. Foo knows that main exists, but main doesn't know that foo exists because it's under it. If I try to bring it on the top, foo must return a value. Well, yeah, we could just do return. Bro, come on. You're messing with me here. Return 0. I can't really type today. What the hell? So whenever I try to do that, as you can see, it's been returned. So, I mean, it's been called. We are able to call it. Our program has been compiled. No issues, nothing. But imagine if your program had, like, I don't know, 20 functions. So, if you want to put 20 functions on top of main, it's just bad, okay? You usually put the main function on the very top, because this is where your program begins. Okay, so you usually put this guy on the top. But that causes an issue. If we put this on the top, then all these guys that come under it will become absolutely useless. But there's a way to do that. And that thing is called forward declaration. Forward declaration means we declare a function before we define it. Alright, so we declare it, then main comes, and then we define our function. And that's the way it does it. That's the way we do it. That's the way it works. So all we need to do is we need to copy this guy, whatever we write here, bring it here, paste it, put a semicolon there. And that's it. Now we have forward declared our sqr function. So now we can do something like this. Int I equals sqr of, come on bro, sqr of 10, which is going to give me 100. So if I put, or maybe just, let's just print that guy out. So we'll just do that. And there we go. So if I do that, as you can see, I've already received my 100. So as you can see, the return type again, this dude right here get replaced by 100. I can even put it here to make it even more clear for you. So sqr of 10 is 100 and is getting replaced by that value because that value is being returned. Now I could do something like this. Oh, this is gonna be the same thing. Where did I do that? I could just do times 5, so it's gonna give me 500 this time. Yeah, just like that. So basically it's going to be replaced. That's basically it. But yes, forward declaration means that you declare the signature of a function before the main function, and then you do it after it. Now, doing this is not just good for this guy. It's not only is it good for this guy, it's good for all the other bullshit. Okay, so you may put another function right here, int foo, int a, return a, or I don't know, maybe int bar, int c, return b, whatever the return b, return c. You could do whatever the hell you want, but then foo can't call bar, bar can't call sqr, foo can't call sqr. Why am I trying to say sql? Anyhow, so these guys can't really call anything that's under them. But when you forward declare all of these functions, then all of them can call all the other guys. And that's basically what forward declaration allows us to do. You can define as many functions as you want anywhere in the code, but you can call any one of them from anywhere because you have forward declared them. Now this is a C kind of a solution, or header files and all that good stuff, which we will learn in a later video right here. Not just yet. But yes, there will be better things when we get to C++ parts, the OOP parts of the C++. This is just, the basics of C, honestly. It's not really that C++ oriented, except these guys maybe. But anyways, and that's the basics of function declaration. So you can declare a function at the top, use it anywhere you want, as long as the thing is under. Now you could declare a function right here. I mean, you could declare this function right here. It's gonna allow you to do that, but main again can't call it. Now let's go for parameters versus arguments. So as you can see, I'm already calling my function, giving it the value of 10, and that is being replaced here by 100, and it's being printed out for me. Now, what the hell am I talking about when I say parameters and arguments? Let me just put that here for the sake of correctness. So parameters are the ones that you put here when creating your functions. Arguments are the one you give them when calling the function. All right. So here we give params. Here we give args. And these are short versions of the contracted versions of those guys. So params and args. Here we give them the parameters. You know, we create the parameters. We define the params. Here we give the args. Okay, and that's basically how it works. Well, it could be like this. Maybe it just has one argument. Maybe it just has one parameter, like in our case right here. And that's basically it. So these are parameters right here, and these guys are arguments right here. I think it's not really that much to go on. But there's one more point to be made right here. The default parameters, like this. Alright, and these guys are like that too. But yeah, the default parameters are the parameters that don't really require you to put anything in this guy right here. Okay, so let's create a little bit of a better function. Okay, let's create a function that calculates the sum of numbers from A to B. Okay, sum of int A, int B. Now the way we do it is, obvious. So we have a sum value which is put to 0 for int I. Bro, come on, bro. What the hell are you doing? I'm hating it. Okay, there we go. So for no, you piece of garbage. So for int equal to A less than B, we just add 1, and then we do sum plus equals I, and then we return sum. Simple, easy, quite easy. Now if I do the sum of 1 to 100, it's going to give me an error because I haven't really forward declared it right here. I'll do that, and it's a good practice to have the same order you have here, as here. So we're going to put that right there. Now if I run it, you can see that 4950. Oh yeah, I made a mistake right here. I need to do something like that, and there we go. I got 5050 as expected. So I can do that and give it the values, the arguments that I want, and it will be replaced by whatever is returned from that function. Now let's say I want my function to be a little bit different. I want it to calculate from whatever number I give it to 100. So if I give it a value of like 5, it's going to go from 5 to 100. It's going to automatically assume that B is 100. Now the way you do it is you go here and give this value something you want. Alright? So B is equal to 100. Now here's the issue. Here's the point. Here's the note that you should be careful of. If you only have the definition and no declaration, all you need to do is give it in the definition, and that's it. It works. But if you have both of them, and if you give them both, it's going to give you an error on compile time. Sum of redefinition of default argument parameter 1. This is a parameter 0. This is a parameter 1. It's gonna give you an error. It's not gonna be happy when you do this kind of shit. So what we're gonna do instead is we're gonna totally delete this guy from the definition, and we're gonna have that in the declaration, and that's gonna be fine and easy. Now, what's this gonna allow us to do is that we can actually just delete this guy and just give it the first number. Now, if I run it, there we go. We have the 50-50 because it's automatically assuming that this guy is 100. Automatically, unless I give it some other value like 50. Now it's going to give me something else. And that's basically it with default parameters. There's another point to be made. Let me just put that in another rule. So rule number 2, default params start from the right. Okay, so we only can give this a default parameter from the right side of the parameter list. If I do something like this, as you can see, default argument not at the end of the parameter list. So it must always be from here. So we always begin from the last side, and we then work our way to the left to the left side. So if this guy is not a default kind of a parameter, this guy can't have a default value. All right. So if I take this out, there's going to be an error. If I don't take it out, then everybody's happy. And that's basically it with default parameters. And there's nothing more to talk about, honestly, except one of the good practices to do. So it's not really a best practice, it's a good practice. Now, functions, well, you know, I already told you, you are free to do whatever the hell you want to do. You can write the names of the functions of variables in any way you want. They're okay as long as you are consistent. If you're not consistent, then just don't code. But if you're consistent, it's okay. You could just do something like this. Int I, int b, int c. Okay? As long as you put 4 or 5 of these guys, you know, underscores, in the beginning of every single one of your variables, because you are consistent, it's okay. I mean, this is kind of an idiotic thing, but it's okay. But if you're not consistent, like do something like this and something like, I don't know, this, then yeah, you're not kind of consistent, so don't do that. But yes, so it's okay to do it in whatever way you want to do it in, as long as you're consistent. Now let's talk about the good practices of functions. Now I've already told you about the naming conventions of variables. They should be camel case. They should. Should is not a good word, but you know, it's not a bad practice to do it like this. So number of enemies, like this. Number of enemies, or sum of apples, or some bullshit like that, right? So you can do it like this. Now for functions it's the same thing, but so we use camel case, but we could also, I mean we should, when we're using camel case for functions, we should put the same, what's the word I'm looking for? Yeah, we should put the same letter, I mean the first letter as a capital. So first letter should be capital in a camel case format, okay, when we're naming functions. And another one that it should be doing is that function names should explain what they do. Now, it's not a must. You could definitely do whatever the hell you want. You could do something like this, see this, and do, you know, whatever the hell you want, return 0 maybe. You could do int just some random bullshit and, you know, return 1, whatever you want it to do, you know, replace it by 0, replace it by 1. But it's a very bad practice, because then you have to comment on the top explaining exactly what this function does. Better to put it in a name than not. Okay, so function names, should is not a good word, but it's better to do that. Okay, so it's better to let your function names explain what they do. Alright, now there are Boolean functions, so functions that can return a Boolean value. It's a good practice to start them with is. Okay, they're trying to give the answer to some value. For instance, is prime. Alright, so you made up a function, it takes an int, and it checks to see if your int is prime. Okay, now you could just write it like check prime, but check prime is, you know, first off, it's not, this letter is small, it's not capital. Second, check prime isn't really a good practice. Better to write it as is prime. Alright, so that's basically it. Is prime, you know, whatever formula you want to put here, it checks to see if this guy is prime, is a prime number. Anyhow, so function names should explain what they do. Bool functions should start with the word is, like this, plus the rest of the function, or plus, yeah, you know, they just should start with is. And these are small good practices that I just wanted to talk about. There's not really much more. I do have a standard guide in my GitHub page. I'm going to put a link to that in the description. You can check it out, read all you want about it. It's inspired from the Unreal Engine standards, okay, from the Epic Games coding standards. It's basically the same thing as that, and I'm going to explain to you exactly how things are in that thing. If you want to, if you're interested, you can go read that out and for yourself. Now, that's it for the functions. There's really not much more to talk about except one little topic, which I'm going to add here, void. Now, sometimes your functions don't really do anything. I mean, don't really get replaced by anything. They just represent, or they don't really represent anything. They just do something for you. For instance, you give your picture to a function and it makes that picture a bit sharper, or it makes it a black and white picture, okay? Those kind of functions return void. So void do something. Void means you don't need to put a return here. You could, you obviously could, but you don't have to, all right? Whenever the function hits the end, it automatically ends the function, all right? So whenever the function hits here, it automatically ends it. But these functions are for the time that you want to do some sort of a procedure, some sort of action, okay? So you want to do something, you don't want anything to be returned, and then you do it. But we don't usually use these guys that much, unless for setter functions and all that jazz. We usually return a bool to see if whatever we did was successful or not, or we return some other thing like result, which is a very common thing, and it's pretty awesome. But yes, it's not useless. We use void a lot too. I mean, in comparison, we don't use it that much, but we use it a lot as well. Anyhow, that's it for this video. Let me just give you the homework for this video, and you can, you know, just go scatter. Anyways, so the homework for this guy, homework, why not? What I want is you write this kind of a function. It's called an int max of, int a max of 2, int a, int b. And what I want you to do is make a function of max. I'm not going to give you the interior of the function. It's just the signature of the function, just the declaration of the function. So make a function like this, compares int a and b, returns the max of both of these guys. So if a is b, we return a. If a is bigger than b, we return a. If b is bigger than a, we return b. If they're the same, we don't care, just return one of them, anyone you like. And then compare 5 numbers to see which one is the biggest. Alright, now the problem with this guy is that when you try to do it with if statements, you're going to write a shit ton of if statements, okay? So they're going to be, is A bigger than B, bigger than C, bigger than D, bigger than whatever. So if all of that applies, then A is the biggest. Do that for B. Is B bigger than A, bigger than C, bigger than D, bigger than F, whatever. We don't really want to do that. It's going to just be tons of code for just a simple comparison problem. But with functions, it's going to be super simple. This is not a hard problem, so try to do this. If you think that it's getting a bit too hard, you're probably doing it wrong. It doesn't really take that much code. Maybe you should be able to do it in less than 10 lines of code, or 15 at the most. If you're going above that threshold, then you're probably doing it wrong. Anyhow, let me just tell you this one little quick note as well. Again, I emphasize there is no reason for you to apply these guys, but it's better to do that. There are tons of functions in the standard C and C++ libraries that don't really use these guides, and they don't really use these kind of practices. For instance, in vector we have something called pushback. snake case. As you can see, we use snake case. The standard libraries have a snake case there. We have sqrt in math, exactly like this. And as you can see, it's already a function that takes a parameter. sqrt square root. So we have these kind of functions and we have these kind of parameters and stuff, but you don't really have to do it. And that's basically it for this video. So thank you for watching. If you have any questions, do leave the comments asking the questions. If you like this video, do leave a like. I would really appreciate it. And if you really enjoyed this, do subscribe to the channel. Thank you very much, and see you on the next one.